everything's set up. Okay. So for those people who are watching via YouTube or whatever, so what we're doing today, and for people who are in person, is we're going to basically look at some ways that you can work with your assignment to make sure that the code is clean, right? So we want the code to be clean between your UI and your main code, and we really want to fix some really major issues. So I'm just going to begin by giving you a quick overview of what we did last time. So we did this MVC thing. MVCs are really, it's a really simple way. It's not always the best way, but for something like your assignment in this case, it's a really nice way because it forces you to separate the components. And so we have the state component, we have this controller component, we have this view component, right? Now a lot of this JavaFX stuff, I'm kind of going to be going through this in a different way. So how we're going to be going through it is we're basically going to extend upon this JavaFX by adding new components rather than me kind of going over the old JavaFX code in a great depth. Now, the way I typically write JavaFX code is I don't use fxml files. I instead use a way of writing it called, it's typically called imGUI or immediate GUI. And the difference between immediate GUI and the fxml way is that you define elements like this, where you create a new label and then you set its position and you do this kind of doing some initialization step, right? And so it's a very different stage where you do it. For those people who are joining, we haven't covered much. We've literally just started. So we have a few things here I just kind of want to go through, point out a few problems in our code, and then we can point out how we can fix those. So we have our main entry point here, right? And in your JavaFX class, it will look something like this. I'm pretty sure the only difference between this code and the dungeon code may be that they put their main function or the main class into a slightly different file, and then they like have this like dungeon application that they launch. It doesn't really matter. I just prefer to do it this way. The other thing that we have here is we have a start function. This is going to be inside your application class. And we basically have a stage here, right? And in JavaFX, stages are effectively kind of like screens is where you can like place things on, right? So it's kind of like a theater is the example they give. So you have a theater stage and you can like place like actors on it or actors doing things, you know, or you can place props that are typically stationary. Maybe they can move around a bit, but they're kind of quite static. And then you can kind of like place various different components into the scene, right? And so this is what we call a primary stage. And so this is kind of like our window. And so we can do things such as set the title, we can set scenes, we can make it show things, and so on, right? The next thing we also care about is a scene. A scene is effectively kind of like an act, I guess you could say, in a play. It's like a part of the play. It's like a specific scene in the play, specific like section in the play. So in this case, the section would be the board. And so the easiest way to do this would just be, as you can see here, we're creating a new view and we're passing the view in as the scene. And the way we do this is a very, very nice trick. You don't have to do this, but it's very nice. I like it quite a bit. Is we have this basically this ability when we chess view, we go through and we create the parent, as you can see here, the border pane, and we go and we create, you know, okay, there's a new chessboard, and we add it to the table, and then we add the table to the parent, right? And so what this allows us to do is this allows us to kind of have this nice flexibility for our view where even the UI inside our view is encapsulated. So like it's that kind of, it's that nice extension, right? And some people go even further. We're not going to do that today. We may do it where we go through a main menu. I may cover that. I don't really think it's that important yet. You know, we can always cover it later. But main menus is really something that you'll be doing like an extension task maybe. So we can always cover that later. And so doing main menus basically just requires the ability to swap the scenes. That's all you're doing is you're creating multiple scenes and then you're just swapping between them to handle the different states of your system. There are other ways you can do it, but that's, I think, the easiest way. So other than that, we have some pretty simple stuff here that's not too crazy. We have a table, which just as you can see, if we mouse over this, oh, it doesn't show a nice table. Sometimes it does. If you see the border pane, yeah, right. This is what our border pane looks like, and our chessboard is going to be in the center. We can place buttons on the bottom, we can text on the top, which we probably will today. And then we have a chessboard here, which matches a grid pane. So it's basically just a grid of individual pieces, right? And we can run the board if we want, and we can have a look at what it looks like. And so I do have some code here that I completed. not all of it, but I've got the pawn moves and I've got one or two other moves. I did that like literally in the last 10 minutes. I was just preparing for this. And so we can run our Gradle and we can see what the board looks like so far. And while that's building, I kind of can go through some of the problems. So one of the big problems is in our chessboard. So we have a chessboard here and we have a series of squares that we create. And these squares are a two-dimensional array, right? And so basically what they are is they're just like chessboard, right? So this is going to be 8 by 8, as you can see here, right? And what we're doing is we're going through our chessboard and we're creating all the squares, and this is fine. But the problem starts here, right? And so the problem here is that whenever we click on a square, we go and we tell the state to move, which is really ugly, right? We're going and making the state do things every time we click on a mouse button. And the chessboard loaded. As we can see it here, we can move our pieces up and down. And pawns actually have proper movement. I did actually add pawn movement. I don't remember doing that. Yeah, I did. Okay, wonderful. And so there's other things here that we can look at. For example, the other problem is the fact that we actually move the piece by setting its position. That's kind of ugly again. You know, the fact that these positions can get out of sync. That was a bug that we found. There's a bunch of other things that are problematic with this, and luckily they all have a very similar fix. And so, you know, for example, the rest of this you don't really have to care about, but we can look at the render function here. I mean, we don't really need this printf. But all the render function does is it goes and grabs all the selected positions that are being attacked. So you get all the possible positions for this object. And for all those positions, it just sets the color based on the position. So it sets it yellow if it's the selected tile, dark red if it contains it, else white and gray. You could change this so it only makes it dark red if it's an enemy piece, and maybe it just makes it like a slightly different color if it's not. You could add circles, you could do whatever the hell you want, right? But the thing that you got to realize this is kind of like CSS if you've ever done JavaScript, right? If you have done JavaScript, it's kind of like I guess you don't need to use JavaScript for CSS now with WebAssembly, but the kind of point still stands. This is kind of like if you used Python with Ninja last semester, you would have had some code that would have had some styling to it. I'm losing my voice. Give me a second. I'm going to get some water. You would have had some code that would have had some styling to it, and this is basically how you do styling. Yeah, so we'll look at that today too. So we haven't actually done that yet, but that is something that we need to focus on today. And so there's a bunch of ways we can do it, but basically the problem here is that our view is distinct when we click on a piece and whether or not that piece is valid. That's the problem. So we actually want to move most of this code to the controller, right? So the controller can decide whether or not when you click on a piece, whether or not that actually means anything. The view should never make any decisions. All the view should do is show the screen. That's it. And so all these solutions are solved by the exact same problem, and that is removing the state from the chessboard. And so we have to find some way that we can remove the state and still have a system that works. And the typical way we do it is we basically use observables. So every time you move a piece in this in the game engine, we also move it in the view, right? And so every time you remove a piece in the game engine, we also remove it in the view. And so it's this kind of back and forth that will give us a lot of flexibility in terms of how we do our design. Anyway, so other than that, the only other thing that's really important for you guys to know, if you guys the other class and all the people watching, is that when you're doing images, right, you always should have a hash map of your images. I'll cover this again later because obviously not up to the UI yet. You should have a hash map of images, and you should always use the hash map of images here. As you can see here, I check whether or not it's in the hash map. If it isn't, I add it. Else, I just create a new view of the hash map object, right? And the reason why I say this is so important is because it's speed reasons. Your app or your application will be super slow if you don't, especially if you have a lot of images. Maybe I'll show off an example later on when I show off. Maybe I'll show like the dungeon application I did, and so you can get some idea for extensions that you may want to do. And I can kind of show you the difference of like how dramatic it was. And I think it was like probably like 20 frames to like above 60, right? So it's quite severe. And the reason why is mainly because you're throttling your IO. It means every single time, especially if you've got a H hard drive, which my computer's actually got a really fast SSD now, so maybe it won't happen. But if you have like a hard drive, every single time you do this, it has to go and read the image. So if your image is a couple kilobytes each, and you're reading for every single image in the screen, you got 20 by 20 board, you got 4 layers, you're looking at like 400 times 4, you look at a maximum of 1600 images being loaded every single time. Each image is like 8 kilobytes. That's a lot of data to load every single frame, every single approximately every few milliseconds. Because every frame should complete in about 15 milliseconds if you want a 60 frames per second system. So it's a lot, and so most likely, especially on slower computers like CSC and stuff like that, where the hard drive is much more hard drive-like, it's not an actual SSD. Oh, I'll give a really good example for composite pattern. I can't really do one for this because chess doesn't really have any composite patterns, but I do have another example. I'll do it probably I'll do it in a couple minutes, maybe like half an hour or something, right? As a bit of a mental break because it's going to be quite a bit of work. Anyway, let's get into things. Okay, so the composite pattern turns out to be really easy. There's 2 ways you can do it. And there's an easy way and a hard way, and the easy way is really, really easy, and the hard way is a little bit harder. Just check my emails because sometimes I get emails from people asking things. Okay, so other than that, let's begin. And the easiest way to begin is just to rip the band-aid off, and we're going to remove the state object. So now we have to try to figure out how to handle it now that we don't have state. This is actually a huge problem. And the answer is basically we need a little bit of state. We need the ability to set up the board using the state object, and then past that point, we no longer care. So what we're going to do is we're going to basically split our render function. I mean, we're never going to call this render function multiple times for one, right? So I'm going to paste it and call it like initial render. Here's our initial render object. And so what this will work is we won't do positions because in the initial render, there's going to be no positions. And all we're going to do is this will need a state object, right? Obviously, to initialize everything, it needs a state object. You could do it different ways. I don't actually think the other ways are as clean as just allowing it to have the state object once to initialize everything. Now, the color here will basically just be white or gray depending upon this condition. So I'm just going to grab this condition and do this. And it'll complain because this needs to have braces around it. So I'm just going to kind of rip the band-aid off, as you can see, grab the pieces. Other ways you can do it here, Aura really cares about pieces. So you could actually just pass me a 2-dimensional array of pieces in this. Or you could have like a query object. So it's kind of a relevancy. Let me find it. So what I did for my dungeon crawler, and you can note this is private, so don't try to be sneaky. What I did for my dungeon crawler is I had this immutable entity query that basically was an immutable wrapper around my thing that allowed me to do everything from like gate victory conditions, ticking my animations, having a consumer that iterates over positions, which was a visitor pattern, and we'll maybe do visitor pattern today. I don't know, but that's one thing you can use. And all this kind of stuff. Now, what I do want to kind of say to you guys is that we do mark you based on how many patterns you have. You need to have at least 3 patterns. I think that's stupid because I think patterns are what you use when your code is bad. And so most likely you will have 3 patterns, but you shouldn't go trying to look to add patterns to your code, right? So rather what you should do is you do what I'm doing here, where I recognize this code is bad. So what I'm doing is I'm trying to fix it by removing state. And by removing state, the only way I can fix it is by using things like observables and other stuff like that. So by fixing it, I'm using patterns rather than using patterns to create problems, if that makes sense. Like I'm not trying to like artificially create a problem that I'm solving with a pattern. I'm actually identifying a severe problem with my code. Okay, now the observable in Java is, to put it lightly, deprecated. To put it less lightly, very bad. So we're going to create our own. You can feel free to use this code for the observable listener. I will ask you if you're going to use it to keep the author, just for the reason why is that it's going to flag plagiarism. So if you have the author there, we don't care. We know that you said it was made by someone. Else, if you don't have the author, then it will obviously, as I said, flag, which is going to I mean, we'll still handle it. I'll still recognize it. But if you're going to copy the code, copy it as is. You can make modifications to it, and you can add your name to the author if you do. But like, the code's very simple, as you can see. So we're just going to have a. Okay. Well, what regards in the problem? No, no, you don't have to come to Tute. I'm just continuing on the code. So there's two ways I could have done this. I could have even basically restarted the code from scratch and done that to you guys. But I thought that wouldn't be as beneficiary as basically taking this as a starting point and looking at other design patterns that we can do from this starting point. Recovering observables, yes. I'm not going to be doing this code. This is basically going to be the last time I do this code, right? Maybe we may come back to it in like a few weeks, but I doubt we will, right? So it's going to be back to normal cheat situation after this. It's just a weird week because this week wasn't really meant to be a cheat, and so the cheat was kind of last minute. I didn't really like it, so I felt this was a better alternative. You don't have to understand any of the code that we've got so far. You can watch the first video if you really want to. I've kind of explained the parts that you need to understand. We're just going to kind of be looking at it from a fresh new view. So let's kind of go over what's wrong here. So the big problem here is that when I click on this mouse, I want this square here to be linked to the game engine. So I'm going to tell the game engine that the mouse has been clicked, right? And not only that, whenever I move a position, I want the view to automatically update rather than the other way around, right? So we're going to create an observable here. Listens to an observable um, event. Sure. Then we're going to give it a param, the type that is being observed. Okay, so what we're going to do is we're going to create a function in here, which is going to be a void function. I guess you call it public void. And it's going to have a, what do I want to do? Updates. I don't know if I like update, but I like listen, but I don't really want to do listen. I think instead I'll just say on updates. I think on updates is slightly better because we're going to pass the old value and the new value. I actually think there's not much difference between the two. Okay, so we have this update function. I'll add JavaDoc for this later for when you guys want to use it. Probably after this. You know what? Maybe I'll just add the JavaDoc now. Just here. Listens is called upon an update. Old value. New value. This is very bad JavaDoc. Okay, it's called upon an update to observable. That's it. That's enough. That's fine. The rest is kind of irrelevant. There's no actually information that we care about. We're going to have a class here called observable, and all we're going to basically do, this class is going to be a bit complicated, but let me just kind of go through what this is. So first off, it's going to be a generic class. So we're going to have generic T, right? We're going to store an inner object. I always do like this. Then we're going to store also a list of observable listeners. By the way, when you're copying, if you're copying this code, make sure you change the package. Okay, so we can create a bunch of observable listeners and we can list. Okay, what do we want to do next? Well, we want to have a constructor, right? See, that's somewhat obvious, right? And this constructor is just going to do a very simple this and a simple listeners. And we're just going to create a new array list. You can do whatever you want, right? So this is, we're going to do this. Again, there's our new list. Really? I really have to do that? Oh, it's the type array list. Yeah, it's the import. I was like, really? It's not going to let me. Okay, I'm just going to have to import everything. Do everything yourself. It should support it. Yeah, okay, it does. Okay. I JavaDoc for this. I guess we'll add constructs a new observable with a fresh empty listener list. Okay. So what happens is this observable is so the difference between this observable and the Java observable is that this isn't a class that you extend. Your whole class isn't observable. You're basically wrapping a single object and saying this single object here is observable. It's a much better design, it's a big reason why the Java version, you can't extend a final class. Extend your final class. It's just I don't. Yeah, I mean you can make it extendable, but I don't really think it should be. You use the T variable. I'll show in a second. You'll see in a second. So I don't observe position. I don't know, observe. I'll just observe. Honestly, that's fine. Observe any changes in this. Listeners to add. And what next? Well, we want to also have a clear function just for utility. Is it not called add? Oh, this should be observable listener. That's fine. Okay. And then we also need and Java doc here, all listeners. So no one is watching. I don't know. There's better Java doc for this. You can fill in the Java doc if you want a better Java doc. You probably should. I just don't want to waste that much time. I'll probably do it if I get better time this weekend. Remove, I don't know, just clears or observables. So no one's watching. That's fine. It's a bit memey, but it's fine. Then we just have an update function, and this is very simple, right? So this update function just allows you to update it, and then you also have a get function that will let you get the inside value, return t. Okay. An object, then you could either have a set. I prefer using update, but set is also fine. And so we're gonna say t old equals this object, then this dot object equals object. All right, so we're saving the old object, and then we're going for each listener. In listeners, and all we're going to do is we're going to call the function. That's it. Okay. I didn't call it listen. What did I call it? Oh, an update? It doesn't even matter. Okay, and I called it underscore object. And underscore object. Okay, and underscore object is just a habit I have where I use underscores to indicate things that are like this class is really just this, right? And so if I made an optional class, I would do the same thing, right? It's to indicate that the whole point of the class is just to hold that object, and that it's not really a proper. It's kind of like this is extending object in some ways, if that makes sense. It's an extension on T. It's just a habit I use. I'm just gonna copy and paste this code just because this will be somewhat similar. Structs an observable event on an object. Okay, so let me show you how it's used. So what we're going to do is we're going to drastically change two things. The first thing we're going to drastically change is we're going to make a decision. Now, this decision is somewhat important, but it is a decision that we need to make. And the decision is whether or not we want X and Y to be observable in the piece object, or whether or not we want them to be observable in the game object. Those are two very important things. Now, what we're actually going to do is create a class that wraps these X and Y's into a single variable because we had a lot of this pair that was running around and I don't really like pairs. So we're going to create a vector 2D that we can observe on. This is just going to be a very simple class and it's just going to have an X and a Y. Is pair tuple. Pair is a tuple that just has two arguments. So it's just a pair of items, like an X and a Y. So for example, I can show you an example here. We have a pair of two integers. This holds two positions each, and this now just becomes a vec2d. Right? It's much nicer. It's nicer. And not only that, it's just a bit simpler. And this has become a vec2d. Right? Okay. So we need a few things for vec2d. We need a very simple public constructor. I'm going to take X and Y. And then another thing we need is, guys may want to do a 3D vector for your thing because you've got layers. And so you can see each layer for like the ground layer, the item layer, and so on. That's an easy way of doing it. I don't like using it, but you can use it. I just think it doesn't add enough types to your program, right? You just kind of like it's okay. It's just kind of it's too abstract for me, and so it's kind of hard to tell what it actually holds. Like, is that a position? Is it X, Y? Is it X, Z? Is it like a rotation? Are you like specifying like rotation of it? There could be much more than just that. I know there's kind of arbitrary examples, but it's doesn't really have a good reason, to be honest. The other thing I'm going to do is I'm not going to allow you to set X and Y. I'm actually going to make this an immutable object. So if you want a new vector, you have to give me a new vector, right? So you can't actually set the vector. It's going to be fully immutable. And the main reason we're doing that is because it makes it really nice to work with in terms of how observable and stuff works. Anyway, so you can add other functions here like length and stuff if you needed them. We don't. So we have a very simple thing. We have this get position state. Okay, we'll need to change the slot. That's okay. Create a new vector. Okay, we do need an equality operator, so let's do that. Public equals. Is it okay? It's not going to help me here. So it's a boolean equals object other in override. Okay, and it just okay, good. It returns. Okay, so let's be really simple here. We're just gonna, I mean, you could even make this final, which means that we can use like instance of and stuff because there's nothing that can inherit it. It doesn't really matter. I'm just gonna do a very simple one. If other equals this, return true. If other equals null, false. If other, we can compare classes like this because classes only have one instance, so they do have pointer comparison. Let me just say vec2d other y equals this. Okay, y. Okay. I mean, you could use equals here if you want. It doesn't really matter. Not really, but if there is, it's pretty simple, right? So yeah, it is very robotic. Other languages just do this automatically, but apparently there probably is. I just typically write it pretty straightforwardly. Anyway, so now we have the equals, so we can do things like contains on it and get correct values. Okay, so let's actually do some work. The easiest ways to do it is just to do this and go back to the. We can ask for a vec in here. We can go this dot. Okay, now we no longer have a set y and a set x. Now we no longer have get y and get x. It's just public vec2d get position. And this may. I don't really use VS Code that much. Awesome. I'll have a look at that later when we need to do another equals, if we need to do another equals. Update position. Right. Okay, so this is where we're actually going to change this. This is going to become observable. Right. Okay, wonderful. So this is a new observable of vec. And we can import this. Let me import it. I want to enter it manually. There we go. Oh, I don't want to use that one. No. Deprecated. Oh, nasty. Look at this deprecated. Oof. I think the code that you're given still uses it. I don't know. You can change your code if you want to not use it. I have a slight recommendation that you do, but I'm not too fussed. Okay. We're not going to return the observable, by the way, because we don't want them to update it through the observable. Well, it actually depends. Honestly, I'm happy for them to update it through the observable because it's going to be the same observable as mine. So like that's the whole point of an observable, right? So I'm actually fine with them doing things like adding listeners to it and so on. you could do it so that you abstract that. It's a bit of breaking of law of Demeter, but it's not that bad. Okay, we're gonna break a bunch of code here because it's gonna complain about all these X and Y's. So now we have to go and change all these. Here's a tip. Let's just do this. Yep, place all those with vec2d vec. It's gonna complain because now none of these have this. Sucks. So I'm gonna have to go and import it a bunch of times, but it's still a bit easier. Java it automatically imports. That would be so nice. Okay. Then we just take I mean, an easy way you could do something like get position, and then you could go like .get x, which kind of sucks. So typically, it's do something like this. Position equals this .get. Then we can grab the x and the y from this. And position .get y. Okay, wonderful. And you could abstract these two if you wanted to break a little bit less of lower Demeter. I think lower Demeter it's like a rule, right? So it's okay sometimes to break it in specific cases. That's gonna break that. Go here to fix that. Oh, of course, bring me back. Well, yeah, you can break lower Demeter in specific cases. I mean, you have to, right? Because I'm gonna add a helper function here to get the x because I think it's actually, you know what's easier? Just like do this. It's not create the object twice. I'll explain that in a second. Okay, and we need a dot equals. And this can just become vec. And then the is white can also become a vec. I don't want to say that many x and y's. I'm gonna be a bit lazy, but slight detriment of not having properties in Java is having to do stuff like that, which is kind of annoying. Okay. That get color. This is becoming a new vector. Okay, so lower Demeter is almost always going to be broken in your program, regardless what you do, because every getter will break law of Demeter. Because the whole point of law of Demeter is that you can't look inside the object. So every time you do a good dot get, and then you do anything on that dot get, you're breaking law of Demeter every single time. And so there's not much you can do about that. There's just two pieces of code that has this. I'm just gonna steal it from the cardinal movement. Okay. And so the trick is to try to avoid breaking it, but it's okay to break it. And it's okay to break it if you have a good reason why. If you don't have a good reason why, then obviously it's not okay. So in this case, the good reason why is that it's simple. And so it increases the readability of our code a lot. So instead of having to have all these replicating all these methods inside this vec2d and copy and pasting all these methods and putting them inside the outer class, like having this .get x .y, but it's more than just that. We'd have to copy all the observables as well. And that's just a lot. And so what this really is this really isn't a class. It's a wrapper, right? This isn't actually, it's more like a structure, right? It's not an actual class. It doesn't really have all the makings of a class. All it does is wrap around this object and just observe on it. It's not really the same thing, right? And the same thing vec here. And the reasoning why we can avoid stuff like that is for the same reason why when you use optional, you don't have to, like you can just return an optional. You don't have to have like a function to return the optional if it's true, else return null. You don't have to like wrap all those optional functions into like special wrappers because the optional class isn't actually like really a class. It's just like a wrapper around the class. So if you have anything like that, that's just like, all it is really just T, and this is just kind of like a very light layer on top of T to give you some functionality, then you don't need law of Demeter because you're not going to break anything by allowing people to expose this object, because that's the whole point. The whole point is to observe it and set it and so on. I wouldn't call it a decorator, and the reason why is because there's not multiple. I mean, yes and no. So generics are a form of decorators. You could have observable of an observable of an observable, but that's just kind of like because they're generic. So all generics are decorators, but I wouldn't claim that this uses the decorator pattern. That wouldn't be right because it doesn't. It just so happens to be a decorator, if that makes sense. Because the decorator pattern is very specific, right? It's like when you have like items and you want to be able to chain effects on top of items, and you have a lot of chaining. So you have like poison on a sword, and the sword also has a curse. You want to chain the curse on top of that, and the sword also has like a buff, so you want to chain things. You may have not. I'll show you an example. If you haven't, there's an image I've got that kind of explains it pretty well. If you want, actually, I've got a bunch of notes. I can send this to you. This was when I took it. I don't know how well these notes are, so keep that in mind. But there's a bunch of code examples of all the different patterns. Some of them aren't particularly great. And Java cheat sheet, I think, has nothing in it. Oh, it's some stuff. Okay. Anyway, I can send this to you if you want. But the one I'm thinking about is decorator patterns. This is a case of decorator pattern. So we have like a file input stream that is surrounded by like a buffer input stream. They're surrounded by a line number input stream. So what this means is that we're basically like kind of having like this input file that comes in that we then buffer. So we put it into like a buffer for speed, right? And then we really just want to count the line numbers. So then we add a thing on top of that to just count the line numbers. And that's what we need. If that makes sense. Anyway, if you want to look at this, you can. Feel free. You can use that as a resource. I don't really care. It's just some notes. Awesome. Okay. Let's go. We want to stuff. Sure, that's fine. What am I doing? Okay, here I am. Oh yes, we need vec2ds. Now, the interesting thing about this is that we want to create this. I don't want to write this amount of code that much. So what I'm going to do is cheat, and we're going to use some regex. B followed by a comma, followed by a space, followed by a D. Wrap these two around. Then you can give me a new vec B of 1, 2. Then we can import it. I'm getting good at regex. Stuff like this is actually kind of quite cool. It's here. I don't know why it's complaining. It's complaining for probably a different reason. Oh, because this doesn't have vec2d. Okay, sure. I've got to add it to all the classes. Don't I? I've got to do that. Reject is kind of awful, but it's also like really, really easy in terms of like you can do a lot of really kind of complicated things using only a few lines of rejects. I don't really have time to go through it. Maybe I'll go for like next week or something. It's really, really awesome. Especially if you like using Vim, it just makes Vim super awesome. Like you can do crazy stuff with Vim. Okay. So we did all this work on observables, and we also have this stuff here. I could probably run a better regex to match this stuff. I don't really care. It's only 2 lines. Okay. But what we haven't done is we haven't actually looked at how we can link this all up yet, right? So we've spent like 30 minutes not doing anything. But the whole point is that we've kind of built up all this technology so that now we can actually do something. No, Vim sub isn't. It's I may be wrong here. But in my head, for example, I don't know how ugly my Vim looks. If you do this, right? Really gonna forcefully make me reload. Okay, sure. The /s, right? The /s is regex. Oh, maybe it's sed. Oh, maybe like using the sed syntax. I don't know. Anyway, so you can go /s, and then you go like g/g, for example. Give some text here to replace with this text here. It may be using sed, which may be slightly different. Anyway, the idea still remains. If you know what it is, then you'll be fine with both of them, right? There should be no problems. Awesome. Let's continue. So we have these beautiful pieces and we can do so much with it. But the big problem here is this move piece function. I hate this so much. My state should basically almost be never told to move. It will just become automatic. So basically what's going to happen, there's two ways you can do this. I'm going to be a little lazy here and I'm going to place the observable. The big difference is I'm making it so that the observables inside the class, I can just move the piece. And when I move the piece, it'll move it here and move it in the view. It's not that lazy. It's not technically that bad design, but a slightly better way would be to do it so that the piece is just a representation of the game state. So the piece links to this state here. So it's almost like the X and Y coordinates here are the observables. It's kind of harder to do it that way, so we're not going to do it that way, but yeah. Piece listener. So we're going to create this piece listener function that basically you can attach. And basically what will happen is this is going to be a function that we're going to attach that will take in a vec2z of the old position and a vec2z of the new position to indicate that a piece is moved. Now note that these can be null. And the reason that these can be null is when you're deleting a piece, right? So it's really quite easy, luckily. If new position equals null, all right, and so I'm just going to say if new position does not equal null, then we're going to say board of old position dot get x, old position dot get y equal to board. What am I doing? All the way around. Let's copy and paste this though. New position equals old position, right? And then what we can always do is we can always go, okay, regardless of what happens, you can set this to null. Right? The piece is moved, so it's gone. And so what will happen is if this is null, i.e. we're deleting a piece, we're still going to send out a final event, right? To indicate that the piece has been deleted. And then we don't actually have to do anything. That's the best part. The piece can still remain in memory, so we can still place it back later. And this is kind of a slight hint that, you know, if you have anything that comes back to life, or for example, like a bomb where you pick it up and you want to put it in inventory, it's no longer on the board, but you still want it to exist. Having the idea that a position can be null is very useful, right? To indicate that it's not on the board. Okay. I'm happy with this. This is good. And we have to handle initial render, but we've got it here. So this render function massively changes now. One of the first things that we do is we basically need to, yeah, sure. Wait, what? It's because it's this dot state. Okay, anyway. And, oh, sure. Okay. So this needs to change. You have to chuck that code in game engine or just game, right? This isn't doing anything yet, but now it will. So we'll have a public void on square click. It's going to take an int x and an int y to indicate that square was clicked. And all we're basically going to do is we're going to move the selected object into here. More than just that, we're going to have a bunch of other things. You can do this differently. Instead of doing a Boolean here, you could use an enum. An enum is probably a little bit better. I just don't want to write that much code. I'm trying to keep my code I'm writing here shorter. Okay. But it's completely up to you. Which there's just, maybe there's a bunch to automatically do all this, and this would save me so much time. But at this point, I'm kind of already. Okay. So x and y we pass in, x and y we pass in. And here, instead of this moving piece, guess what we have to do? It's really, really nice. We just go selected dot set position. I guess we go get position dot set new vec 2d xy, which we probably means that we probably want to do. Oh, you know, we could, let's make this even better. Let's just pass vec 2d in here. Right. And then let's use this vec everywhere in our program just to make things slightly cleaner. We'll also even have get piece use a vec. I mean, maybe not. It doesn't really matter. I think stuff like this, you can make a decision. But you should probably be a bit more consistent in this, but for time reasons, let's not take forever. Anyway, so we have this ability to click a piece and so on. Something that we want to add to this. is that, for example, we only want you to be able to select a piece if this piece is your piece, else we don't want to do anything. So what we're basically going to do is we're going to say, else if you click anywhere else, I'm always going to turn this is selected to null, right? Because if it's like a deselection. And if this dot selected, I guess the best way is just probably just to grab the piece. You know what? Let's just do it this way. So we're just going to do get piece, and we're going to say, hey, if this dot selected dot get color equals white, this could be much better. A much better way of doing this would be to, I can see it here, right? We put strings would be to have these as constants in your program. And if you have these as constants or have them as like enums is even better. But I think I did it for this reason because I want to use the strings later on. It doesn't even matter. This probably should be changed, right? No. If the get color equals white, you know what? Because of that reason, we're actually probably going to do this here. Oh, I hate that though. Okay, we're going to do is white move. We say if the color equals white and is white move, there's too many cases. You kind of just want to do a comparison against them. Okay. I'm just going to say player equals white. Okay. You know what? I got even better way. Let's do it this way. I'm changing my mind too much. Okay. So if the color does not equal is white move, white or black, then we can set the color selected to null. So all we're doing, we're just basically saying, hey, if you click on a different piece that isn't your piece, it won't select it. And you can kind of do the same idea for enemy turns and your turns. Obviously, the enemy turn is going to occur right after your turn, right? So you don't really necessarily have to like block the input of the player. It's just that you don't want to like check the input of the player until their turn. So like it should be a bit easier for you guys, typically. So with this pair here, and we're just going to change all of our pairs of integer, all become a vec2d. And most of these will already have it imported, so we shouldn't see too many issues. iMovement will need to be compiled and we'll need to have an import. Once it's compiled, we should see both these codes compile. Great. This should be a new vec2d. Why don't we just again do this? Be a new vec2d. Okay. Wonderful. Okay. So most of our code looks like it's compiling right now, which is pretty great. And instead of being get key, it's going to be get x and get y, which is again much better than the key and the value thing. Okay, so we have this position code. We can do all this other stuff with it. That sounds pretty great. And we no longer need this code. So all we can do is whenever we click on a mouse, we're just going to basically send an event to the game engine. So what's the easiest way to do that? Well, we can take the game engine in our constructor here, and you don't have to do this as a constructor. You could also, it's called chess engine, isn't it? You could also do this differently. And there's a slight recommendation here that this code is like nice because the board doesn't require the engine other than to like set up events. I call it, I don't remember what I call things. But you could have it so this is a separate function, or you could have it so that the engine like calls the view and asks the view to set an event. Yeah, that's the whole point. That's exactly the whole point. You got it. I don't even need the view. I could just turn it off and play a game chess. That's what you want. If your game can't do that, you have a lot of trouble making tests for it. A lot of trouble. So engine, on square click, new vec2d, X copy, Y copy, and there's a big hint here, not a big hint, but just like a big recommendation that whenever you're doing lambdas, any variables used inside the lambdas, you should save outside. And the reason why is because if I just use X and Y, these values are going to change after this function call gets made. Because this function call isn't made now. This is a future event. This will occur sometime in the future. I don't know when, right? And so when this occurs sometime in the future, there's no random call even. What will happen is that the X and Y position could be the very end of the array, right? Well, most likely the very end of the array, unless you're super fast at clicking. Okay, so we're almost done. Yay, we only have one more event, which is update render, which guess what is very easy. So all we have to do to update render is we basically just have this function here. Because see how we grab the square here and we have the state. Well, what we can do is we can also go piece equals alpha chess. What do you mean by alpha chess? Like AlphaGo or something? I don't know. Hey, yeah, that's exactly the point. And so what you'll see is you'll see that we use something called what I can't believe I've got the name. Strategy pattern. We use a strategy pattern to choose the AI for the enemy and the AI for the player, or I guess not AI for the player. And the reason why that works is because everything's so abstract that the player's move is not really a move, right? So we can still have the AI select a piece, right? We can just say the AI clicks on a square. And we can also do other things, for example, and this is really important. Let's say you want to do touch move. You touch a piece, you have to move that piece. You should not do that inside your view. Your view should never care about touch move because that doesn't really make sense. That's a game engine thing. How do you test that? Because you can't test your view. But if you have this on square click, you can say, well, if you've already got a piece selected, you can't click another piece, right? That's not allowed. You could do stuff like that. So you have logic now inbuilt inside your engine. Anyway, so we're going to add some observables. And how do we do this? Well, it's very simple. We're just going to say add, well, what's it called? Observe, sure. And we're going to say old value and new value. So we're just going to create another lambda. There's another way to do this, which is to use this function down here. I actually think the lambda here would just be a bit cleaner in terms of the amount of code we require. Let's see. So we're just going to observe this, and what we're going to do is, and honestly, I'm just going to even put up here. Is we're just going to say, hey, we know what the X and Y position is. You're just going to move the piece. That's it. I mean, technically, we can grab it from old value, new value. I guess we'll do that instead. Because the X and Y position actually won't always be true if we move it twice. Okay, that makes sense. So what we say is we say if new value, right, this is not equal null, then we're just going to repeat the same code that we did before, where we say, we're basically just going to swap around the labels. That's not actually correct. We have to swap around the graphics of the labels, which kind of is a bit bizarre, if that makes sense, but it is still what we have to do. And the other thing here is that keep in mind that yes, I can access state here in this function, but I don't really necessarily want to because that's kind of just a bit ugly, right? My view shouldn't need to access the state here. So it's kind of just like a promise that I'm going to make between me and the state. And the other thing you notice is that I don't actually even need the state here, other than to do initial render. So the initial render I'll require, but not past that. So what will actually probably happen is this initial render will be public, and what we'll do is we'll actually pass in the state for that initial render, and we'll remove it here. Right? And so that kind of removes that dependency or that ability. Oh, we do need it here to get the piece for that position, so we can access it. We could also do that for the engine. You know what? This is fine. Okay. I'm fine with this. This is okay. And then we'll just do initial render down here. Okay, end state. Also, where's my styling? So this is now that we're just going to do a squares of old value or new value rather, X and new value. Y image. Or can we go X as the graphics? There's a few things we can do, but we basically just want to set the graphic as you can see here. But there's the set graphic value. There's also probably a get graphic value maybe. Yes, awesome. Okay, great. So we'll have a node here called temp, and this is equal to the, well, I guess we don't even really care what the old value is, right? So we're just literally going to set the graphic to null. Easy. Wow, okay, that's much easier. Okay, so we're just going to say this dot set graphic of new old value. So we're just going to copy and paste this code and change it to old. And dot get. Wonderful. Okay. And then we can go further and we can say that this set graphic equals null. So we're just going to try this out. We may need to make a few other changes, but this should be basically enough to get to where we were before. We won't have colors because we haven't done that yet, but we could do colors like here, for example. So to do colors, we're going to do that slightly differently. But anyway, we'll see. So we have a chessboard, which will require, I guess it will require the game engine. That's fine. But other things that we don't actually care about state, we don't have to hold the state anymore. The state no longer becomes an important part of the view, which is kind of nice. It just becomes an argument to construct it. Okay. And so, by the way, for these relationships here, you wouldn't call this an association. You would call this an association. You wouldn't call this an aggregation. That's the big importance, right? This is associated to the state, right? But it's not actually part of the state. You may have different opinions about doing this stuff, and that's obviously perfectly fine. Oh, we have the initial render out here. Let's do even better then. We'll put the initial render outside the class. I kind of like that. So we only render it once on the board. Okay. That's going to basically set up the board given the state. So we can run that more times if we want to reset up the board. Easy. Okay. What's next? Well, we have this chess view here, and we have to pass the state in the game into it, or the state in the controller. And that's basically it. So we won't get any visualizations, but we still should be able to move pieces, because what will still happen is it will still trigger the events. And so we'll still be able to trigger these events here with this square click. So we're just going to try rerunning it, of course. Really? Okay. That's not going to work, is it? It's going to be shooter projects. Okay. So what we've covered so far is we've covered in quite a bit of depth the pattern of observables, as well as obviously we covered other stuff as well. Okay. Exception, null point exception. Okay, line 40. Okay. Oh yeah, piece could be null. Okay. Easy. This. And we can retry. And that's, by the way, how you really quickly read errors is you scan down and you look for the last caused. Don't care about anything else. Just literally scan down, look for the last thing that says caused by, and this is the lines that cause your errors. Everything else is just a stack trace that you don't care about. This is the only thing you care about, is the last caused by. Okay. So I've got a different board. It's not moving anything, but it's kind of hard to tell why it's not moving anything. It could be just because it's not selected or something like that. So what we can do is we can add more events, right? So events are a very good way to interact between your systems. So a big event would be on regenerate visuals, right? This is going to regenerate all the visuals, and this is an event that you can subscribe to. It should, because we're moving around the graphics. It could be something else. I don't really know until we actually regenerate all the graphics and we can see whether or not it's even clicking on the piece. It could be another reason too. For example, we are setting it here, which will trigger it, but there could be so many different reasons why. So we're not going to, I mean, the one thing that's actually slightly problematic, well, this should be fine. When you play a Pi game, would you say? Yeah, no, it should refresh. It should refresh automatically, which is nice. Subscribe to visual refresh. So I'm going to call it visual refresh. This is not the refresh you're thinking of. This just allows me to add visualizations. And so you just need a consumer. It's just a function. And you're just going to take in a series of positions, which is just going to be a list of vec2d. And these are all the positions that you should highlight. And right now, we're just going to basically highlight it based on what's on that square without any context of the state. So we could add more complicated things. We could even have a function called so we tell you, we call this for each position and we tell you what you should color the positions. But I think that's too work in the game engine. I kind of want to put that to view. So wait, yes, it's a consumer. Yep. So we can just have, we give a list of consumers, but in this case, I'm just gonna have a single consumer just because I think I only want like one visual event. You could add multiple. It's really up to you. And we set this to null originally. I guess it is already null. Okay, so you've clicked on a square and you've actually selected the tile. Therefore, we want to trigger the visual event. Right. Now you could also have this return a result. You could have this return all the positions and the change of those positions given this, right? So there's various different ways you could do that. You know what? That's better. Let's do that. So we're going to have this on square click return a series of positions, right, to indicate all the positions that should be highlighted given this event, right? So if this dot selected does not equal null, we're going to return, we always need a list, positions, new array list. And all we're going to do is we're going to say, gosh, where is it? It's this dot selected dot get positions. Easy. And we have the state because this is the controller. This controller should have the state. That's the whole point. And let's return positions. What does this return? That's kind of weird. Okay, sure. I guess I still want to set it to new here because if it's null, I don't want to return like a null. I just kind of return an empty list. That makes much more sense to me. Okay, easy. So now we have this function here. It returns something and we can grab these positions. Okay. Is it not going to let me do that? Okay, sure. It really needs to be some kind of like order so you don't have to like retype the name every single time. And then all we have to do is just do this second render function, right? Basically just do what we're doing here. So we're just going to copy and paste this. And this gives us all a nice little square coloring. So this is going to be update visuals. And serving state is now going to have a list of vec2d positions. Okay, so we're going through for each one. We're going to say, hey, we're going to call get color instead of this. Right, positions vec. And the other thing is we're removing selected. So we will make selected red, but I'm actually okay with that for now. So we'll just kind of remove that code. We'll come back to that kind of stuff. And vec is just going to be a new vec of xy. Okay. Vec2d. So often when you're doing stuff like this, and we don't need to get the piece anymore because we already have created the piece. So all we really have to do is just, and we already know the pieces are correct. We just have to color them. That's it. That's all we're doing here. Is just coloring the pieces. Anyway, so the one thing I want to kind of know here is that yes, the code will be initially look a bit more ugly because we have, for example, we have less features here, but the whole point is there's less features, the features that were kind of hacky originally. So we removed all the hacky features and now we just have, pure features that exist in the language. Yay, this is kind of good. The reason why it's kind of good is because I click on something and nothing updates. So that's actually pretty good because what it means is it indicates, right, that we're not doing anything. For example, we're not actually calling the function. But if it did do something and didn't work, it would have been worse. So let's do this. We can see what the issue is. Because obviously it's still not moving it, but it could be a few issues. Okay, wait, so let's have to look at game engine here just to check. Okay, our selection should not be null. We should grab all the positions, check if the positions contains it. Oh, we're always grabbing the positions. Oh, but sometimes we don't down here. Anyway, I guess. So let's see. Oh, that's interesting. It's still not doing anything, right? So we go over here and we look at this. It will re-render everything. So why doesn't do anything? And the reason why is because we're returning positions here, but the positions must be null for some reason. So we're asking the state to get a piece for x and y, right? And that's for some reason null. So the easiest way is probably just to do a print line. I mean, we could do debug as well, but honestly, just do a print line and just see what it is, right? And this would be a good reason why you would have toString method, but we do not have a toString method. So we'll just do this. So what we should be able to expect what the value should be, plus. Okay, because we kind of know our logic in our head, and so we kind of know that, okay, this stuff is fine, so the problem wouldn't be this, you know, because it was working before, so we can kind of realize, okay, if I click this button, what happens? So I clicked one, let's say this one here, we can see that we're getting 4, 6, 3, 6, 3, 6. So if we click this one here, what do we get? We get 0, 6. That's fine because it starts from this edge. It's kind of weird, but sure. Like we're still getting positions, right? So if we're still getting positions, it still should have a selected. So what we can do is we can try to print out what selected is and see whether or not it's null. Okay. X and Y, X and Y. The other thing is that this order could be the wrong way around, but I doubt it. It looks honestly fine. Let's go and try rerunning and see. Okay. We have a pawn. It's clicked the pawn. The logic here is fine, right? So what's going on? Well, it's clicking the pawn, so maybe it doesn't have positions. So we can check those, right? It should have positions. And then the other thing, if it does have positions, would be this is the console for debug. Oh, can you guys make? Oh, yes, the console, when you run your program, there'll be an output window inside VS Code that will work. Oh, look, it works. There's 2 vectors. Okay, so if there's 2 vectors, then what does that mean? Well, that means that without a doubt, we should have 2 positions, but we don't. So this event is being called, and we're grabbing the positions from this, and we're calling this function called update visuals. It's definitely here. And we're going through each one, and we're grabbing the positions, and we're grabbing for X and Y for every position, and we're seeing whether or not it contains vec. So for some reason, this is returning false, right? So an easy way we could do it is we could just say return dark red. Right? This basically is going to make everything look dark red when we update the visuals the first time, but at least would tell us whether or not it's wrong. And the other issue could be with we could have an incorrect this. That's fine. It's fine. That's fine. Get X, get Y, get Y. Yeah, that should be fine. Like if it isn't, then we got another problem. Yes, I click the board and it goes red. Okay, great. So the problem is twofold, right? And this is kind of where it gets a bit bizarre. So So debugging here may actually be useful because we don't necessarily know. So it's saying the positions does not contain it, which would indicate that we're reaching this kind of like comparison and it's failing. So what we could try to do is we could try to just build a really simple test and see what the result of that is. It's probably gonna be quicker than actually checking the value. So we're just gonna do a system.println. It won't make a difference, but sure, I'll change it. I mean, it was literally all red, so that works. Why don't we try this? We'll try just doing a simple comparison. So we'll say vec dot equals, what's the vec that we clicked on? 3, 6. So we expect this to basically always be, so it should be vector D, always be true. Easy, okay. Well, not that easy, but a little bit easier. If position dot contains vec, that should be fine. Okay. Let's have a look and see. False. Did I click on the right pawn? Let's say 1, 1, 2, 3. Was it that pawn? Nope. I mean, we can just click them until we start seeing true. So it's always returning false, right? Why? Oh, well, this is where debugging comes useful, right? So debugging here is annoying, but basically what we want to do is we want to check what part of it fails. So for you guys, you can just press run button and it'll work. For me, I have, because I've got this set up, I'll have to like link a debugger to it, which is way too annoying. So instead, what I'm just going to do is basically just, oh, let's fix that. There we go. Sure your equality is correct. If the classes are the same, then that doesn't mean that equals is wrong. Anyway, you'll meet something like that and you'll spend hours fixing it. So that's just kind of a bit of life. Yeah, it works. Okay. I can see the board works, except for this point here, so we can fix this quick bug. Look for the first null point exception, line 31. Right? Okay. Just game, line 31. If this dot selected does not equal null, and this dot color. Okay, wonderful. But basically done in terms of this first step. Now we actually want to do turns, and then we're basically, I don't know, there's not much else after that, right? Okay, so that was a bug that took like 10 minutes to fix, but we're most basically done at this point. I guess all I really want to do is twofold. One, I kind of want to talk about the movement system because that's to do with the two, and talk about how that works and talk about ways we can kind of change it. And then two is I want to be able to take pieces, right? And then finally, right, I also want to be able to well, there's a few other things I want to do too, but we'll handle those as we come. Let's just talk about the movement system. So for those who are, weren't in Wednesday, the thing you guys missed was this movement system. And so this uses a pattern. There's a few, there's only one name for it, but it's, as I say that as I try to remember what it's called. I got a huge mind blank. It's strategy pattern. I literally, for some reason, I can never remember that. I forgot that twice today. So we have the strategy pattern here, and all it basically is allowing to choose a strategy at runtime. So for example, our bishop is going to move diagonally. So when we create a bishop, we add behavior to that bishop that says it's going to move diagonally, and it can move this many squares. Our king, for example, can move cardinally, and it can move once, and diagonally once, right? Awesome. Okay. So let's look at our chess game and let's see how we can take pieces. Taking pieces turns out to be pretty easy, right? So all we're basically going to do is we're going to say, hey, if this dot is not equal null, grab all the positions. If this is a valid movable position, then we're going to set the position. But the thing here is that we're checked whether or not there's no piece. Else if it can, so actually I'm going to grab this and change how this thing works. So we're going to grab this here and we're going to move this inside. So it's still a valid piece. If there's nothing on that square, go ahead and move there. It doesn't really matter. Right? No, we're not checking for, oh, remove checked positions. Yep, okay, don't really care about that. So note, make sure to check for moving into a position that will check you, right? You can't obviously like move your queen or you move your king, wherever, such that that would put you into check. We're not checking for that right now, we'll check for it later. And all we're basically going to do is say, hey, it's not null, so there's a piece. So you have to grab that piece. So if the piece does not equal null, then what we're going to do is we're going to be able to take that piece, right? Now we know that the positions are valid because it won't give us positions for the opposite enemy. So we know this is a valid position. We can just take it. So we can literally just say piece.get position dot set null. That's going to take it off the board. Selected dot get position dot set back. Now we have a bit of repetition here, but I just kind of want to indicate that you could simplify this, but I kind of want to keep it like this because we're going to be checking. So I don't really know what the code's going to look like. So I don't really want to presume anything yet. Okay. Wait, before we do this, let's do turns because turns is pretty interesting. Okay. So we're going to have, we're saying here that, hey, the piece has to equal the color. So what you would have noticed is I couldn't move the black pieces. So now we've made a move. What we're going to do is we're going to say is right move equals is right move. Right? And we actually are going to simplify this code because to not simplify it would require more work. So we're going to do this, and we're going to say turn count plus plus. Okay. So now we have a movement system with turns. And it loaded, and we can't move the black pieces. As you can see, we can move these pieces. Now we can't move the white pieces. We can move the black pieces. We have almost a game chess, but now we can't move the white pieces either. Oh no! Oh, we can't move this bishop because apparently this piece is not a movable position. I mean, we can move this. We can have a look at like what the values are here. So it seems like, oh, well, now we have to move black. Okay, that makes sense. So it seems like a cardinally doesn't work, but everything else kind of does. Okay, well, we can see if there's anything else. Oh, that's interesting. I don't really know where that's coming from. Oh, it's saying I could take. Oh, yeah, because I set up the pawns wrong. The pawns don't have proper movement. Anyway, we'll fix that. So there's a few things here. It seems like only pawn movement works. So well, let's fix that, right? Pawn movement's fine. Yes. Yes, it is the exact same, Joseph. It's just the way it works. So you're setting it to the opposite of what it currently is. Cardinal movement, reach position. Yes. Grab the position. If the reach position equals not, state of the positions of that point. So here's a really easy way that we can basically make sure it's always going to work. And the really easy way is that we can make it a bit hacky. So we have our chess view here, and to make sure that nothing's going wrong, just in test, what we're going to do is we're just basically going to have it re-render the entire screen every single time you click on a square, right? So we can do this initial render. And so what this will do is this is just a really nice way for us to be able to tell whether or not there's something wrong, because what it will do is it will re-render all the pieces, right? Okay, so what it means is if, for example, we're moving pieces out of sync, and that, like, for example, that's why. So even though we're moving our pawns, they're not actually moving or something like that, we'll be able to see it because we're not just doing a delta. So we move this piece here, it seems to work. Oh, but we click a piece and it moves back, right? So it seems like when we click a piece, it reverts the change, which typically would indicate that this piece is actually, oh, wait. Oh yeah, that would typically indicate that the piece is like kind of not really moving, right? You know what we probably should do is remove these observables here, if false, and because these observables are probably mucking up like the piece moving, and whenever you, yeah, so we'll try that as well. Anyway, it doesn't really matter. The problem is going to be somewhere to do with game state. If new position does not equal now, the new position dot x, new position dot get y equals old position dot get x dot get y. Okay. And we're always setting the old position to null. Okay, so this moves here. Huh. Look at that. Right. So the old position isn't actually moving. I mean, we can try this. We can see that it seems like the piece is here. And the reason why is actually, I believe it's not removing the old piece. If that kind of makes sense. It's kind of this like weird thing, right? Because here we move this piece here and it's saying that I can only move here, which means there must be another piece here. So it's almost like it's duplicating the pieces. Which is kind of bizarre and doesn't really make sense. So, because this is a class, right? So we should be copying the class across, and it's not copying reference of the class and moving across. Anyway, so what we're going to do instead is we're basically just going to always null out. Oh, I know what's wrong. My God. Okay, so here we observe the position changing, but the state doesn't observe the position changing. So the state also needs a position. I'm just going to put it here. What did I call it? For goodness sake, I called it piece listener. Sure. And then we can re-enable our old behavior. I mean, we could decide not to, just try to keep behavior similar. But But the problem here is that because it wasn't actually moving the pieces, they were kind of moving this like weird view thing where they were like not really moving, but they were still moving. Like the pieces positions were really moving, but not in the state. So the state thought there was a piece there, right? But the piece thought it was somewhere else. And so there was this distinct difference between the two sets. Oh, beautiful, it works. Okay. I just wanted to test it really quickly just to make sure, because else it takes too much time to go across. We can move the initial render. Yay, awesome. And so that should work, right? So stuff like that, it's fun to fix things. Anyway, so we have this things here, and we can move our pieces up if we actually click on the right square. Thank you. And oh, we got to move the back piece. I got so scared for a second. I was like, it's not working. But yeah, no, it is. I can move this piece here. I can take. They can take. I can move up. They can take. Is it their move? This is interesting. Oh, I didn't fix the pawn movement. The pawns think they're going down apparently. So these pieces think they're going down, but these pieces they think they're going up. That's probably a pretty easy fix. That's probably just me going. If y equals 1, you do this. Oh yes, I always do that. Oh, so then instead of doing this, just means you just get the color of the piece to decide this. White moves up, black moves down. Oh. Okay, let's do this. Now our piece will be fixed, right? And that also fixed the other issue we started to see. Now this code here is kind of ugly. So if you were to write something like this, I'd recommend not to write something like this and instead kind of actually have a lot of these things be variables, right? Have intermediary values. But we only have 15 minutes and we have a little bit of stuff left to do. So I'm not going to waste the time on that. I'm not going to get knight movement done today because I don't think we really have time. It's just like an extra movement script that we don't really need to do. So instead, we'll just kind of have like an end game state. I think we're moving them the wrong way. It was black move down. I don't know what way my board goes. I think this is 0-0 and this is like 7-7, which kind of makes sense because that's the way we do it. But I don't know. We'll have to see. Okay. Here's. I'm not gonna move you. I'm gonna move you. Oh, look at that, beautiful. Take, up, move up, take, move up, and so on. So one thing you could do is you could have like you could turn different positions. You could say, hey, if there's an enemy piece there, I want to label it red, else I don't. You know, there's so much variability that you can do in your game, and we can do most of that from this. Like we don't actually need context. Like we can tell whether or not there's an enemy piece there by purely looking at the board state. So we can literally say, hey, if this contains vec, and we just do it this way. If squares of vec dot get x of vec dot get y, if this dot get graphic, if that does not equal null, then we're going to give you dark red. Else, we're just going to give you yellow to say that you can move there. So like a lot of the time, your view doesn't actually need a lot of information, especially for you guys, right? Your view needs very limited information. And so limiting it to literally nothing, which is what we have here, like it can't even look at like what even is there. It can only look at like the image of what's there, right? So if you limit it, you'll typically find that you get quite nice code, right? The code will be quite simple. It'll be nice, extendable. And so, for example, currently we can do stuff like this and there's no check move, right? So really what should happen is that none of these pieces should be able to move because the piece king is in check. So what we need is we need a checker. So that's pretty easy. I'm going to kind of cheat with this a little bit and just do a very easy get checker. So we're going to say public in check. And the other thing that we're going to do is we're going to look for the king. So we're going to have this a special piece here called king. And we're going to say, I mean, there's technically two types. So we're going to have like the white king and the black king. And then we're going to say, this equals white, black king, this. And we can fix these up a little bit nicer. I've got an interview like at 1:30, so I won't really be able to go that much overtime as I would. Yep, so we have white king and black king. If anything I don't get through this, I'll go through a video afterwards so you can actually maybe see like a final product or something. I don't know, who knows. In check, all we have to do is just say, look at the game and go, hey, get me the king. Wait, I don't have a function for that. I'm just going to do this. This is easier. Again, you probably need for this. I am getting annoyed by the fact that it's on enum, but it's fine. Okay, so we have to stay here and we're going to get the king for his white move. Okay. So basically what we're going to do is we're going to do two things. So we want to say, hey, if it's your move, right, you can't move to any position, right, at all that would put your king in check, for one. And for two, you can't well, okay, so that's one important thing. And for two, you also can't sorry, I'm thinking. So you can't move into any position that would put you into check, and you also can't make any other move other than a move that would put you out of check. So what we want to do is we want to see whether or not the result of a move would put you out of check, right? So this is the move. Is okay out of check. Is out of check. Okay. So all we want to do is you basically want to go, okay, here's your move. If you make that move, is it going to put you out of check? Simple as that, right? So all we're going to do is grab all the list of moves that you asked that you can do. So these are all the positions. Well, it's more than that. We kind of have to grab like every position of every single thing in every single position. We have to grab a position for every single like enemy square, and we have to like check whether or not the positions are valid. So we can do that, right? So we'll just have like a function to do that. To grab all the positions. Vec to the enemy positions. Boolean is white. And so what we're going to do is we check the board. We're just going to do this even easier. I'm just going to use I less than 8. Then so X. Then we're just going to do Y. Okay. If it's Y, then we want to check whether or not the piece color. Oh, let's do it this way. Piece do get color. Piece is not equal now, and piece do get color not equal equals is white, but false. Right? And then we just want to grab all those positions and return them all. You can go positions. Really? I know, I'll just wait for it to load. Yeah. Positions dot add all. Wonderful. And then we go piece. Positions. Okay. It's going to give me all the positions for this piece, and for only enemy positions, return positions. And all we're going to basically do is check whether or not those positions are attacking the king in any way. And then what we can do is we can move a piece and then basically check the positions from there, right? So there's a few ways we can do this cleanly. The easiest way is that we basically want to make positions changes, check them and then change them back. But that's going to like make the screen flicker. There are ways to get around the flickering, and the ways to get around the flickering is to basically tell the view. So the view like tracks all the changes somewhere and only applies it when you tell it to, or to basically make it so you can make changes that don't actually force a change, like don't actually cause observables to trigger. Or the better way is just to pass in changes that you want to make and reflect them. We're just going to keep it pretty simple. We're just basically going to go, okay, if this move is going to put you out of check, let's get all the enemy positions. And then all we're going to do is we're just going to check whether or not all those enemy positions are, for one, are they going to, not necessarily are they going to attack the king, but if those positions target the king, if that makes sense. So for example, if you move a bishop out of the way, those positions are going to target the king. And so for that reason, what we actually want to do is we actually want to kind of almost have like a function to get all positions that ever, but it's kind of a bit annoying. So instead what we're going to do is we're going to make that move, then we're going to check the positions, and then we're going to, if that makes sense, right? So what we're going to do is we're going to say, or rather we care about what piece we're making the move. So we're going to say this dot selected dot set get position dot set position to move. If enemy position dot, I guess we can reset it back. I mean, it doesn't really matter. We can say if enemy position dot contains king dot get position get, then obviously the king's going to be in check, right? And then we can just return true. Else return false. And the other thing is, if we return true, we're actually going to unset this, else we will contain that move as an actual valid move. Or maybe we won't. We'll always undo it immediately afterwards, maybe. This kind of makes sense. So we'll go set back to the old position of the piece. So we're going to say vec2d old equals this just selected get position. Get set back to old. Okay, if position dot contains vec, good, and is out of check, vec, right? Then we will allow you to make that move, right? Else, when we grab all the positions, we want to make sure that we only show you the positions that are valid. So we want to show you the same thing here, right? So you can kind of see that basically, where's it? Oh, and that's actually a valid error. We the problem here is obviously we're setting the move and resetting every single time, which kind of sucks. So a classical way that we could do it would be to, instead of having to do this a bunch of times, instead what we could do is we can just and there's a bunch of other problems with doing sets like this. It's actually going to lead into problems where like pieces disappear and stuff. So effectively, you could try to like grab the observables and freeze it. That could be one way, so you don't trigger observables. Or you could basically do what I'm going to do, which is have a set function that doesn't actually trigger observables. So it doesn't actually move the state. Anyway, time-wise, this is basically it. What we can do is we'll still show you all the positions, but we'll only let you do a position if it moves you out of check, right? This would be false actually, and this would be true. Okay, because doing the other way around is a little bit more tricky. And we're done after this. You'll be able to move your pieces around. Obviously, we don't trigger state, but to trigger state, you basically just have to check whether or not the number of positions that you have is 0, right? If you can never make a position, then it's either stalemate or it's I'm just going to try to like create a example. Check, just can't show it. So I'm going to move here, and we're going to see that if we try to move this piece here, for some reason it's not letting me move this piece, but if we move this piece like here, we can do it. That's like fine. We can like take this piece here. We can try like move these, but it won't let us do it. It will only let us make moves that will be beneficial. So we can't do this, we can't do this, but we'll be able to do this. If that makes sense. And then we'll be able to take this position. I think these bishops on opposite colors for some reason seem to be broken if it's on the color of your square. I don't know. I always forget what turn is. Okay, it's this turn. Let's move this piece down here. Let's move this piece up here. Oh, it's back to this turn again. Let's move this piece down here. So it seems to just be this bishop doesn't like moving here for some reason. Or it could just be diagonally down. It doesn't work. Yeah, no, diagonally down would work. I don't know. We can have a look at that quickly. Oh, yeah, it should be Y. Less than chess dimensions. And it's greater than or equal to 0. Sure. If this is less than chess dimensions and less than chess dimensions, sure. If the subtraction of both of them are greater than 0, it's fine. Oh no, I'll talk about the lab. Well, the lab was in the first part of today, right? The lab was in the first hour, but I'll talk about the lab for the next 10 to 15 minutes. Don't worry. But I won't be able to do any more of this stuff. I said I was going to talk about it, so I definitely will talk about it. Anyway, I don't know why it's not allowing the bishop to move. You can move this one here. If I move this guy here, for example, oh, now it does, just not from this position. So it could potentially be like a desync. Unlikely, but potentially. I mean, I guess the easiest way to do it is to basically just see what moves you can make as black here. So you can go down to white can still take this piece. So it seems to be this like weird thing here. Maybe it's like it's not allowing me to move because it like sees a piece or something. Who knows? It doesn't even matter. Not too fast. That's kind of weird though. You can move here, and I can move this piece up here. You move down here. I don't know, move this piece up. You can move back up, but you can't move back to. Oh wait, I always forget whose turn it is. You move back up to here, but you can't move anywhere else. It's kind of weird. Yeah, it is just like when you're on the top row, it doesn't let you move. Oh, I know why. This is less than equal. It's so no. It's gonna be something. It's gonna be like one of these greater than equals is not right or something. Anyway, because it's basically saying that you can't move down a piece when you're on this top row only. So it's this like bottom left corner here. So like X is decrementing and Y is decrementing at the same time. So it's these. And it's saying, hey, this is when they're both decrementing. This is when X is increasing and Y is decrementing. So this is this one here. And this is this one here. For some reason, it's failing. And the reason probably why is because, I don't know. I guess because Y should be increasing rather than decrementing. The direction. Oh yeah, we're missing a case. That's why. Anyway, so that's the problem here is that this should be incrementing. I'm pretty sure, because the Y decrements downwards like this. So this is negative Y. So you need to handle like negative Y and negative X. And you also need to handle like positive Y and so on. So for example, this thing here should actually be X minus I is greater than 0 and Y is less than chess dimensions. Or something like that. Doesn't really matter. Let me go to the lab. So the lab has a composite class, right? So what's a composite? Well, a composite is it's basically allowing you to state that an object is made up of multiple sub-objects. And so yeah, it works now. Yeah, okay. Anyway, so let me give you an example. So a good example would be for your grade thing, right? So with your grades, you have like assessment tasks, right? And each assessment task is made up of like a certain weighting scheme. So let's say the weighting scheme is, I'll stop sharing this because maybe people want to listen to this, doesn't really matter. So for example, maybe your scheme is an average mark. So if you get an average of, I don't know, 20%, it's a pass and so on, right? And so that's what your grade is. And then you also have the actual weighted mark of the assessment itself. So for example, you may have an average mark of the assessment. So like grab all these assessments and average them together, and that's your final result. So for example, typically 2511 has a really nice, not really nice, but it exists. Yeah, here. So this is the scheme. So what's the total course mark is just everything averaged together. So this is like a really basic one. But if we just like comp2521, right? Um, 81. I feel like WebCMS is having a bunch of problems today. Yeah, WebCMS um is really struggling, which is a bit interesting. Anyway, so we have WebCMS here, and it has 2521 here, and it has a bunch of labs. And the key thing about these labs is there's a few things, right? So for example, all these complicated things. So the assignment marks are made by the sum of the two assignments, right? And then what we do is we grab the harmonic mean of these two assignments, as you can see here, right? As well as so we got the assignment marks is equal to the adjusted assignment percentage, which is equal to the assignment percentage that you had here, which is all your assignment marks, which is equal to this, right? Plus the practical exam marks, which is the final exam, times by the practical exam as well, right? So effectively, it's constructed such that it looks something like this, so that the lower your practical exam mark, the lower your assignment mark. So if you got 90% your practical exam, 100% your assignment exam, assignment percentage, whatever, it's 95%, right? You don't have to care how this works. The only important thing is that we want to apply these different means and stuff to it. So how do we do that? And so what we do is we have classes that contain other classes. So a case would be okay, I don't know. I don't know if I really want to do too much of this code because it's the whole point of the lab. But the example, we have to do harmonic mean, right? So harmonic mean is made up of two things, right? So harmonic mean is a bit unique in that you can really, I guess you can calculate a harmonic mean of multiple. It's just the sum divided by the multiplication, the product divided by the sum. So we'll just do that. So it's just like a private list of assessments, sure, whatever you want to call it. And then we also have and then we also have a private, I guess this is a public function, doesn't matter. So we're gonna have a public function called getMark. And what it's gonna do is just return assessments dot sum or product, I guess. This is a magical function. I don't know. You can build this function yourself. It's gonna be a reduce. You can do a stream reduce. You could be like dot stream dot reduce, and then for each one, it's like a times b times by 1, so it's going to multiply them all together. And then you could do the same thing for your sum as well if you want. You could reduce it down. It's going to be a plus b 0. And you can do all this like crazy if you want, or you can just have loops. Loops are fine as well, right? And so what you're doing is you're like reducing these sets down into and there may be compile errors here. This is not actually going to compile the code, but the idea still remains. I don't know, something like that. And so you have your marks here, and you're kind of summing up your marks as you want, right? But the important thing is how do you get these marks? And so each one of these is going to be like get mark. And so each one of these could be harmonic means as well. So effectively, you can have this like a nesting effect, kind of like a decorator pattern, where you have like nesting of each of the subclasses inside of each other. And so, for example, you have assessment that could be another harmonic mean, or it could be a grade, or it could be anything, and it's all like reduced in here. And so you may have your simplest one as being simple assessment, right, which may just be like a pure mark, literally. right? Something like that. And so this is your simplest assessment, and this is a slightly more complicated harmonic mean one. Or you could do even more crazy stuff. I mean, there's an example here. Gosh, if I remember what it is. Milestones. There is a lab, but yes, there is actually a lab though. There's a week 5 lab. A composite. Here's an example, right? So we have a composite leaf node. There's 2 ways you can do it. I gotta go in like a few minutes, but there's 2 ways you can do it. You have a leaf and you have a composite here, right? And so the idea here is it's lab 5, isn't it? You already saw the observer pattern, right? You can use the observer Java class if you want, but you've seen it in this, so you know how to use it, how they work, right? You have to Google it to figure out how the Java one works compared to my one, or you can just use my one. I don't really care. It doesn't matter. But you can see this is the one that you go do. So we have the composite pattern here, and we have a leaf and a composite node, right? And so the thing is, this is like my mark, right? And then this is my overall operation. This is my harmonic mean. So I could have functions inside here, like public void add sub assessment. Right, and so this could be a new list, array list or something. So then it could be like this dot assessments dot add a, sure, right? Does that make sense? That you can kind of have this like structuring where it like nests inside of each other. I think Jeremy asked the question originally. Does that kind of make sense? You're doing is that you're basically creating like 2 versions of the class. You're creating one version of the class that's very simple, and these all of these will implement or extend the assessments depending whether or not this is a abstraction or not, right? And this is like another example. So this is like if you do uniformity, so they've got functions in both of them, but these will crash. That's the point of it. You want these to crash. So I much prefer this. This is much nicer. But you kind of have they're very different between the two. Like this. So you add each of the sub milestones into this. So you like a dot add sub assessment milestone 1, dot add sub assessment milestone 2. Or you can just like pass it in the constructor. And then when you get mark, you're gonna sum all those up or do the product. Feel free to send me your code if you're struggling with it too, and I can kind of like point out where it's gone wrong, or anyone, right? Anyway, I gotta go. I gotta prepare for a freaking interview.